Today's lesson is 4.1, Properties of Quadratics. Today we're going to take a look at the characteristics of a quadratic function, or more commonly called a parabola. It has two different forms. Let me just zoom out a little bit here so you can see the whole thing. It has two different types of forms. We're actually going to talk about three forms next, but right now we can talk about our standard form, which is ax squared plus bx plus c, where the A, B, and C that are in color are are three different numbers that you would see. Since the A and the B are being multiplied by an x, if they are equal to 0, then they would make the x value disappear. Of course, if A is 0, I would make the x squared disappear, which means I would not have a quadratic. We have seen the vertex form before. We've seen it to do our transformations. And so now we're going to specifically see it for our quadratic function. All right, we have these different characteristics that we need to talk about. So let's go ahead and get started with our axis of symmetry. The axis of symmetry is a line that divides the parabola into two parts that are mirror images of each other. Two parts that are mirror images of each other. It does have a formula. The formula to find the axis of symmetry, which I like to use the abbreviation AOS, equals negative b divided by 2a. Now, what you might like to see here is this b in the blue color and this a in the purple color, because these numbers are coming from our standard form. Now, of course, when I write this function in as an equation, my AOS, which is axis of symmetry, is going to become the variable x. The axis of symmetry is a vertical line that goes right through the vertex. So we would graph it just like this. Here is my axis of symmetry. And of course, it goes down below as well. All right. The vertex, which we have seen in the past, is the point where the parabola reaches a maximum or a minimum. Remember, a maximum is the highest value of your graph. A minimum is the lowest value of your graph. Here is my vertex right here. And for this graph, because it is facing upwards, this vertex is a minimum. To find the vertex, I would use vertex form, and it would be the ordered pair H, comma, K. So if I use the vertex formula right down here, H, comma, K is my vertex. Remember that H is tricky and it is the opposite of the sign that you see every single time. All right, let's go ahead and talk about the y-intercept. This is the point where the parabola crosses my y-axis. Okay, this is the C value. This is the C value in standard form. So when we are in standard form, we know that the y-intercept is going to be whatever that C value is. If we take a look here at our graph, we simply find the y-axis, which would be this one right here, and we notice that it is crossing the parabola is crossing the y-axis right here at this point. So this would be my y-intercept. Remember, the y-intercept is an ordered pair. It is a ordered pair x comma y, where the x value is always 0. All right, and the last one, let me change to my blue, is the x-intercept. This is the point or the points, as you can see right here, sometimes there are two, where the parabola crosses, oops, the x-axis, the x-axis. This, the x-intercept or intercepts are also known as the solutions. Sometimes you'll hear me ask you, what are the solutions to this quadratic? Or the roots, or the zeros. Any of these names are exactly the same. So I could ask for the x-intercepts. I could ask you to find the solutions. I could ask you to find the roots. I could ask you to find the zeros. They are all the same things. Let's go ahead and take a look at what they are. So here's my x-axis, remember, is my horizontal axis. And we're just looking at the parts where the parabola touches. So my x-intercepts would be here and here. Why are there two? Because of that x squared. All right, are there always two? No, and we'll see that later. All right, just a quick reminder from the vertex form right here that we can use the vertex form to help us show the transformation of our parabola from its parent function. So remember this guy right here is going to reflect or flip your graph over the x-axis. So this is going to determine if your graph is upward facing or downward facing. If the negative is there, we're going to call it downward. If the negative is not there, then we're going to call it upward. And we could, there we go. The A value, remember the A value? Let me go ahead and move this, see if I can do it. There we go. Remember the A value is going to stretch or compress our parabola. Remember we are stretched when we use factors like 2, 3, 4, when my factors are whole numbers. And we compress when we use a factor of 1/2, 1/3, 1/4, any type of fraction, we're going to think of that as being compressed. All right, tricky, tricky H. Remember, H is going to move your graph from the left or to the right. To the left or to the right. Remember, when we move it to the left, it looks, we would think negative, but it's going to look like this inside. And when we move it to the right, it's going to look like that. Now, of course, remember, H is going to become a number and the square is going to stay there. That's because it is a quadratic. And lastly, K. K is the one that moves my graph up or down, and K does what K says. It, which K thinks, what you think K does. So when you think up, I think plus K, and when I think down, I think minus K, and that's exactly what K does. All right, I hope that was a quick reminder. And then let's go ahead and take a look at some graphing. We're going to graph today in standard form, in intercept form, and in vertex form. All right, so here we are in standard form, and here is my first equation. The first thing I'm going to do is I'm going to identify what A equals. Let me grab my blue, what B equals, and of course what C equals. To do so, I'm just going to take this standard form and lay it right over here so that everything lines up. As I do that, I can see that A would be right here, B would be right here, and I'm going to grab the sign in front of it, and C would be right here, and I'm going to grab the sign in front. A is 1, B is -2, and C is -3. Now I can go ahead and I can find the axis of symmetry. From the last foldable, I know that the formula for the axis of symmetry is -b divided by 2a. Remember, we already talked that this B is that blue B and that A is that purple A. So let's go ahead and substitute in our numbers. The equation has a negative, so when I substitute in the -2 for my B, I need to see it double because there is a negative in the formula and a negative for B. So I need to be careful. I need to see them both. The formula has a 2 and A is 1. Negative, negative is going to become +2 on the top, and 2 times 1 is 2. 2 divided by 2 is 1. I squeezed it in there, yay. All right, so there's my axis of symmetry. It is at 1. I can grab my blue and I can go to 1 and I can put a vertical line. Somewhere on this line is my vertex, and I'm going to figure that out in just a second. I also know my y-intercept. Oh, hold on. I used a different color. I also know my y-intercept. My y-intercept is my C value. My y-intercept is my C value, so it's simply going to be -3. I'm going to go to my y-axis. There it is. Ooh, oh no, let me leave that color. And I'm going to count down to -3, and I'm going to put a dot. Now remember, because the axis of symmetry is there, I know that there's a dot the same distance away from this one on the other side. So I can put my dot right there. There we go. Perfect. The next thing I'm going to find is I'm going to find my vertex. Now remember, we talked that our vertex is an ordered pair. It is an ordered pair and is going to be H, comma, K. I don't really have H comma K, so what I'm going to do is I'm going to graph this and I'm going to figure out what my, oh no, I don't have to. I know that the X value is 1 from my axis of symmetry, because remember my axis of symmetry is my X. So I know that the X value to my vertex is going to be 1. I know that H is 1. So how can I find K? Well, I'm simply going to plug 1 into the equation right here because remember this is X and this is Y. So I'm just going to say, let me do it like this. Y equals 1 squared minus 2 times 1 minus 3. I'm going to go ahead and I'm going to put that in my calculator and I get -4. There is my K value and here is my vertex, +1, -4. I can already tell that this parabola is going to open upwards. I know that it opens up because my A value is greater than 0. There's no negative at the beginning. And so I know that the graph is now going to look like this. The last thing I need are my x-intercepts. And I can simply find them by putting this in the graph. I can find this by setting the equation equal to 0. I can do this by getting a table. But anyways, my x-intercepts are going to be here at -1 and here at +3. There we go. Let's put it together. Let's see how this does. No, not so great, huh? I'll do the best I can. There we go. Perfect. There is my parabola. Let's try a second one. So here it is. Once again, as I quickly look at the very beginning right here, I can already tell that my parabola is going to open down. Why can I tell that this one is opening down? Well, because my A value is less than 0. This time my A value is going to be negative. And if I look right here, my A value is going to be -1. My C value, since I have the color already, is going to be the -3. And my B value, which is always with the X, is going to be +4. All right, let's go through and let's find our axis of symmetry. Remember, we always start with our axis of symmetry, which remember has the equation x equals. Here's the formula one more time, and that's simply so that we can figure it out faster. All right. Remember, there's a possibility of being a double negative. And yes, you want to make sure that you take care of it. All right, no double negative in the top. Basically, all you're going to do in the numerator of this fraction is decide, is it staying negative or is it becoming positive? This 4 is staying negative, and in the bottom, you're just going to be multiplying your A value by 2. Now you can go ahead and divide, which gives you a +2. If you do trust yourself putting this in the calculator, you could go ahead and put it in right from here. I do highly suggest that you use your fraction feature and that you use the parentheses. All right, somewhere on that line is our vertex. Let's see what else we can find. We do need our y-intercept. Remember, our y-intercept is always equal to our c value. Our c value is -3. So we're going to go to our y-axis, which is our vertical axis, and we're going to go to -3, 1, 2, 3, and we're going to put a dot. Because of our axis of symmetry, I can count how far away that dot is from the axis. It is 2, and so there is another point 2 away on the other side. I don't even need to look at the table. Let's go ahead and find our vertex. To find our vertex, we're going to take our x value from our we're going to take our x value from our axis of symmetry, and we're going to use it to find k. So we're just simply going to go into our equation, our original equation, and we're going to plug in that x of 2. Let me go ahead and plug it in. I'm getting this equation once again. This came from right here. It's just these x's are going to be changed to the 2. I went ahead and I put that into my calculator and I ended up getting y equals 1. That means that my vertex is the ordered pair 2, comma, 1. Now I can go ahead and I can graph this. 1, 2, Oh, that doesn't look right. Oh, no, yes, it is. That looks right. I was thinking, oh no, let's try positive one. There we go. I was thinking that doesn't look right because I was thinking my parabola opened like this again, but nope, it opens down. It's going to look like this. All I need to know is where is it hitting the x-axis. Remember, for my x-axis, it is going to be a y equal to 0. So I could go ahead and do 0 and solve this, but we could just go ahead and put this in the calculator, or you could go ahead and um, do a table, anything like that. But it's going to hit right here at +1, and then of course right here at +3. Now I can see the shape of my parabola. There we go. Remember, this function is more U-shaped. Our last function was V-shaped. All right, standard form. Let's go ahead and move into intercept form. You might be thinking, why all the different forms? Uh, some of them are easier to graph than others. Some of them give you more information than others. And so we're just going to go ahead and take a look at the different forms. We can always tell if our graph opens upwards or downwards by looking to see if there's a negative right here. So my graph right here does not have a negative value, so this one is going to open upwards because my A value is greater than 0. There's no negative there. There's no negative there. All right, I can go through and put my vertex form, A parentheses x minus p, close parentheses x minus q, and I can figure out that A is going to be 1 because this is where A should be. I know that P is going to be, okay, now be careful. P and Q are going to be tricky, just like H is. Notice I can tell this from the formula. I can tell this from the formula. So P looks like it's +1, but it's really -1. And then Q, let me grab my green. Q is going to do the same. It looks like it's -3, but it's really +3. So what does this mean? This means that my intercepts are at P and Q. They're at P and they're at Q. So my intercepts are going to be at -1 and oops, that was supposed to be green, and +3. So I can go ahead and I can go to my x-axis and I can put -1 and +1, 2, 3. There we go. Now, because they are, because because of the way they are, I know the axis of symmetry is going to be P plus Q divided by 2 because the axis of symmetry has to be right between these two numbers. Now, if I don't have a graph, this is how I'm going to find it. If I have a graph, I could simply count 1, 2, 3, 4 and divide this by 2. But I want to show you that you can do the math as well. Let me change this to black. I'm going to do -1 plus +3, and I'm going to divide that by 2. So right at 1 is my axis of symmetry. Remember, this is x equals. And take a look at this. Take a look at this. Just like I said, 1, 2, 3, 4. You divide that by 2 and you get 2. This is not the axis of symmetry. That means you count 1, 2, and there's your axis. 1, 2, and there's your axis of symmetry. So it's going to let you know where it is, but it's not going to give you the number of it like the formula does. To find my vertex now, I can go ahead and take this, which I know is my x value. I can plug it into the formula to find the y value. So to find my vertex, that's exactly what I'm going to do. I know that the y value is 1. To find the x value, I'm going to go ahead and plug it into the formula, and I get -4. To do that, all I did was I said 1 plus 1 times 1 minus 3. That's exactly how I found the -4. This one, no, sorry, this one and this one came from the axis of symmetry, and this is how I got the -4. I can now go ahead and plot my vertex, 1, 2, 3, 4. And that's good. That's going to be enough. There's my graph. All right, let's take a look at another one. I'm hoping that what you're seeing here is that each one shows me something different. Notice that there is a negative right here in the beginning. So this graph is going to open down because my A value is less than 0. All right, my A value is -1. Oops. -1, there we go. My p value is also going to be, oh, nope, it looks like it's -1. It's really +1. Tricky, tricky. And my q value, it looks like it's -5, so it's really +5. I now can find my y-intercepts, or sorry, no, not my y-intercepts, my x-intercepts. I can find my intercepts. There we go. And they're going to be at 1 and 5. Remember, they're always at your P and your Q. 2, 3, 4, 5. There we go. To find my axis of symmetry, I'm going to go ahead and take P and Q and add them together and divide by 2. So P is 1 plus my Q, which is 5, and I'm going to divide that by 2. That's 6 divided by 2. That is 3. My axis of symmetry is right here at 3. You might have already counted and gotten that as well. You can do that. Remember, that means your x value for your vertex is going to be 1. The x value for your vertex is going to be, is going to be 3. I need the purple. There we go. And to find the y value, I'm simply going to take that 3 and I'm going to plug it back into the original equation for the x. I really like the vertex form or the intercept form because it doesn't have an, there we go. It doesn't have a square for me to worry about. It just has the parentheses. There we go. There is our parabola. All right, the last form we're going to talk about graphing in today is our vertex form. We've seen the vertex form before. This vertex form is going to help me And on this one, I'm also going to talk about that increasing and decreasing again, and we're going to talk about our domain and range. We can look to see if our graph opens upwards or downwards by simply looking at looking for that negative in front of our A value. There is no negative, so this graph is going to open up. This graph is going to open up, and we know that is true because A is equal to or is greater than 0. There's no negative. Our A value is going to simply be 1. Remember, H is tricky. H is tricky. There's H. H looks like positive 2, so H is really negative 2. And here is K. K is the real deal, negative 5. What I like about this one, going from here, um, I I know a lot of stuff. My axis of symmetry, I don't have to use a formula because my axis of symmetry is simply H. So remember, this is X. H is negative 2. So at negative 2, there's my axis of symmetry. And I can go ahead and put it down like so. I also know my vertex. Because remember, your vertex, when you are in vertex form, is simply H, comma, K. So this is like the easiest vertex to do because we already have identified H and we've already identified K. Oh my goodness, there we go. Let's go ahead and graph that. 1, 2, 3, 4, 5. There we go. And then we could just make ourselves a table to figure out, and we could just use -1 and 0. And then we could, of course, go ahead and figure out then what's on the other side. So just by simply making a table, we can figure out that there's a point here at -1 and -4, and that there is a y-intercept at 0 and -1. Due to the axis of symmetry, there's 1 on this side, and there's a point right here. And there's the shape of my graph. There it is. There's the shape of my graph. Um, the domain for this graph, would be, let's see, I'm trying to change the color. There we go. The domain for this graph would be all real numbers. So I would write it as -infinity to +infinity. This would be the domain every time, because we are always going to see those arrows of continuality. There's very few times where you will not. Our range is going to be very similar to how we did it with the absolute value. So you have to be aware of where your positive infinity is and where your negative infinity is. And you're going to look at the arrows of your graph. That's why they're very important. They should be pointing at one of the infinities. This is the one you want to use. And then the number that you're going to use is going to come right here from your vertex, and it has to be the y because range is the y. So which one comes first? Well, remember, first is always negative infinity, second is always positive infinity. So since my arrows are pointing towards positive infinity, the y value goes first. So this is first and this is second because positive infinity is always second. So my range is going to be -5, comma, positive infinity. Infinity always gets a parenthesis, and because the vertex is a closed point in my parabola, it's going to get a bracket. My graph, I can do my increasing and decreasing just like we did for our absolute value, reading our function from left to right. Remember, the arrows are not showing the direction. The arrows are not showing increasing. The arrows are the arrow on the left is showing you where to start. So this is our start, and we're going to go down to the vertex. So this side is decreasing. This side is decreasing. And then at the vertex, it takes a turn and goes up, and so it is increasing on this side. Sometimes you see them as absolute value, or you see them like we did the domain and the range. If you see them like this, you would say from negative infinity to the x value of your vertex, which is -2, and then increasing from -2 to positive infinity. All right, I think there's one more. All right, this graph I know is opening downwards because my A value is going to be negative. It is less than 0. Okay, let me see if I can go through this one faster. Ah, there we go. So A is going to be -1. Let's see, H. Remember, H is tricky. H looks like +2, so it's really -2. And K is not tricky. K looks like +3, so K is +3. All right, my axis of symmetry, remember, is simply H. So my axis of symmetry is -2. I feel like we just did this one. No? No. Okay. All right. My vertex, there we go. My vertex is going to be the ordered pair, H comma K. Let me see, let me put them up like this. H, which is -2, and K, which is +3. Let's go ahead and graph it. 3, there we go. And then I can go ahead and use my table, or um, I can use my calculator to find a point right here at -1, and then here at x equals 0. And then I can use my axis of symmetry to give me the other 2 points. And there we go. There it is. There's my parabola. My domain, yep, you guessed it. It's going to be -infinity to positive infinity. And my range, let's see if we've got our range. You're going to get your y value right here. And you're going to look, is it positive infinity? Or are they pointing at negative infinity? So which one is it? There's my y value. Which one are we pointing at? This is where the arrows come in handy, because look at that. They're pointing right at negative infinity. So negative infinity goes first, and then +3, because 3 is a point on the graph, it's going to get a bracket. All right, and then if we do increasing and decreasing, let me change that color. Remember, you always start on the left, so you start with the left arrow and you read to the vertex. So we're going up, which means we are increasing. And then at the vertex, we take a turn and we start decreasing. Whew. All right, let's go ahead, and the last 2 examples that I have for you today are to write the equation from the graph. Now, what you want to do when you write the equation from the graph is you want to decide which one of the three forms we talked about, vertex, intercept, or standard, would be best. Now, I would actually pick between intercept form and vertex form because standard form is kind of hard to write in. And the reason you want to look between intercept and vertex form is which one do I know? So we're going to go ahead and we're going to mark the vertex. Here's my vertex. Do I know what it is? Nope. I can't tell what it is on this graph. It's hanging out there in space. Let me kind of zoom into it for you. It's kind of hanging out there in the middle. I would be making a guess as to what it is. But if I quickly go and I look here at my intercepts, remember when we talk about the intercepts, we're always talking about the x-intercepts. I can tell you that this x-intercept right here is going to be 2. This one is 2, and that this one is at -1, 2. This one is at -3. Those are the x values for them. So I'm going to go ahead and I'm going to use the x-intercepts for this one. For this one, I'm going to use the x-intercepts, which means I'm going to be using, I'm going to spell this wrong, intercepts. There we go. Which means I'm going to be using my intercept form. So I'm going to go ahead and use this form. Now, of course, to help me out, I'm going to grab my color because it's going to help me to show you how I got these three numbers. Now, if you've already guessed it, you know P and you know Q. They are the two intercepts marked on the graph. It doesn't matter. Make the left one P and the right one Q. It doesn't matter. You already know them. Yay! How do you find A? To find A, you just need a point on the graph. So we're going to use this form and a point on our graph. All right, well, we have a point on our graph. We have a point on our graph. We have this point right here. This is the point that we're going to use because we know it is the ordered pair 1, -4. All right, here we go. So um, let's start to find our A value. Remember, when we have an ordered pair, it's always x comma y. So we're going to use the form right here, and we're going to plug in for y, we're going to plug in for x, we're going to plug in for p, the x again, and for q. Here we go. Y is going to be -4. We're solving for the variable a. A is who we're solving for. Then we're going to say x is 1 minus our p, which is -3. X is 1 again minus our q, which is 2. All right, there we go. And now we're going to go ahead and we're just simply going to do some math so that we can solve for a. Well, this is going to become 4, and this is going to be -1, and we are solving for that a value. It is more proper to go ahead and put that -4 in front of the a, right? The symmetric property allows us to do that. And to solve for that a, I'm going to divide both sides by -4. And I get 1 is equal to A. So now take a look at what I have. I have A, I have P, and I have Q. I can write my equation. The equation of this line is going to be, I ran out of space, y equals 1. I don't need to put it. X minus 3, which just turns into a plus, x minus 2. There's my equation. Sorry, I ran out of space. There we go. All right. Sorry. All right, I have one last one for us to do, and let's do this one really quick. If you notice from this one, I do know the vertex. There's my vertex right there, and I can actually tell you that it is the ordered pair -3, -2. This is going to be, oops, there we go. Remember, this is my H value, and this is my K value. So the beautiful thing about this is I can use my vertex because I know my vertex, which means we're using the vertex form. All right, we already know H. We already know K. We already know if it's negative or not. I already know that this one is not negative because it is opening upward. The only thing we need to find is A. Just like in the last one, we're going to use the formula and a point on the graph. And a point on the graph. So let's go ahead and find a point. Any of these points will do. Any of these points will do. Oh shoot, hold on guys, this one's different from what's in my notebook. Hold on. Oh no. Let me fix this. Here we go. This one is different. 1, 2, 3. Oh no, -3. 1, 2, -2. Okay, it's just hitting at a different point, it looks like. Well, it doesn't matter. Let's see. There can be my point. My point's a little bit different, which is at 0, comma 1, 2, 3, 4, 5, 6. There we go. So there's my X. There's my Y. Let's go ahead and start filling in. So Y is going to be 6. We already know that the A value is going to be positive, so we can drop that. We already know that H is going to be -3. We're going to get that squared up. And we already know that K is actually -2. All right, so here we go. All right. Oh, no, I had to put X in. What am I doing, you guys? Oh, y'all. X is 0. So 0 minus -3, minus a minus is a plus. So that's 0 plus 3. That would be 3 squared. That would be 9 minus 2. So I really have this equation. Let me just move it around for you guys. There we go. And we're just going to solve this two-step equation. We're going to go ahead and add 2, which gives us 8. And we're going to go ahead and divide by 9. Yuck. Yucky, yucky. It's going to stay that fraction. That's okay because all we have to do is write our equation. We're going to put our A value, and then we're just going to write minus the -3 squared minus 2. There's our equation. It wasn't pretty, but we got it. Good luck, you guys.